Hello everyone, Assalamu alaikum. Our paper ID is 4061. Our paper title is Performance Analysis of Machine Learning Based Traditional and Ensemble Technique for Smart Grid Stability Prediction. I am from the authors and presenter. My name is MD Shakib Hassan. Here is the presentation outline. Here is the motivation and research gap. Traditional power generation resources are limited while power demand is steadily increasing, necessitating a system to minimize power loss during transmission and distribution. This demand shift has led to the evolution from conventional grids to smart grids, which leverage high-speed communication, networks, sensor-based technologies, and artificial intelligence. Research in the smart grid domain has predominantly focused on hardware and communication aspect, with limited exploration for AI for smart grid stability prediction. Addressing this gap, the comparison study between machine learning-based traditional and ensemble techniques aim to enhance evaluation matrices for smart grid stability prediction. So, finally, implementing AI for smart grid stability prediction is not only improves grid stability but also enhances customer satisfaction by accurately predicting power demand. Here is the background and literature. Some papers purpose model is MLP, cost sensitive, stack ensemble classifier, and ensemble bagging technique and XGBoost. Here is the dataset is 10,000. Predictive factor is 12 and accuracy has 90 up. Here is the research objectives. First of all, develop advanced ensemble machine learning techniques for predicting smart grid stability, enhance prediction accuracy and reliability compared to traditional methods. Conduct a comparative analysis between proposed ensemble techniques and traditional methods. Validate the effectiveness of ensemble technique in addressing smart grid stability prediction challenges. Here is the methodology. First of all, we use smart grid augmented 60,000 datasets. Next, data pre-processing, missing value, handle missing value, and then we using we can split two division, train and test, 80% for train, 20% for testing. Okay, so next, employ machine learning based traditional and ensemble techniques are employed. Then the hyperparameter utilizing, and find the comparison evaluation performance of the traditional and machine learning based ensemble techniques, and finally the find best techniques for predicting smart grid stability. Here is the description of features. We use 14 features in our paper. Tau 1 to tau 4 is the reaction time. P1 to P4 is the power P1 is power produced, and the P2 to P4 is the nominal power consumed. To consumer 1 to consumer 3. G1 to G4, G1 has elasticity of producer. G2 to G4 is price elasticity for consumer 1 to consumer 3. Here is the our targeted column is StabF. Here is the showing stable and unstable. It is the categorical binary level 0 or 1. Result and analysis. First of all, comparison experimental result of traditional machine learning classifier. Here is the evaluation outcomes of the traditional machine learning classifier. Here SVMC has the better evaluation outcomes compared to the other traditional machine learning classifier for predicting smart grid stability. Then we comparison experimental result for ensemble bagging and traditional machine learning classifier. Here is the we can see that bagging technique has enhanced evaluation outcome compared to the traditional machine learning classifier for predicting smart grid stability. Then comparison of experimental result of ensemble boosting and traditional machine learning classifier. So we can see that when we also apply ensemble boosting for predicting smart grid stability, so it has enhanced evaluation outcomes compared to the traditional machine learning classifier. So here we can see that here is the ensemble stacking technique methodology. First of all, we use a data set for training. Then we choose some traditional machine learning classifier for the base classifier models, and it is the learning stage. And next step, predictive value in stack ensemble. We use meta classifier model. Model is logistic regression model. So finally, final prediction. Then we can find out final prediction of the smart grid stability. So we can see the proposed ensemble stacking classifier evaluation outcomes. Here is the evaluation outcomes of ensemble stacking techniques. He has accuracy ensemble technique ensemble stacking technique accuracy is 97.77%. It has the much better compared to the traditional machine learning for smart grid stability prediction. Here is the then finally we use voting techniques for voting techniques. We can see that voting techniques evaluation outcomes. Here is the hard voting accuracy is 95.23% and the soft voting is 95.26%. So it is the much better compared to the traditional machine learning. Finally, we use hyperparameter tuning settings for the best parameter and best value for the machine learning model for predicting smart grid stability. Here is the conclusion and future work. Finally, we in this study compares to the traditional and ensemble technique based on machine learning with the proposed techniques excelling in testing. Finally, we can analyze that. We can analyze that ensemble technique has the much better to the single traditional classifier for predicting smart grid stability. And the future expect is while the dataset used was not large, future research could explore efficient feature engineering based models and updated algorithms to address the challenge of handling real-time smart grid stability. So thank you.